Today we're going to learn about a new parent function. This is the rational function. F of x equals 1 over x. It is called a hyperbola. It consists of two symmetrical parts called branches. Here is the parent graph. It has a vertical asymptote of x equals 0 and a horizontal asymptote of y equals 0. Remember, asymptotes are lines that the graph or function approaches, but it never touches. If we look down here, it tells us how we can graph a rational function. The first step is to draw the asymptotes. X equals h and y equals k. Given the function, you should be able to tell what is h and what is k. And then the next step would be to plot points to the left and the right of the vertical asymptote. Then we draw two branches of the hyperbola so that they pass through the plotted points and approach the asymptotes. Here's an example. Now let's move to the bottom. It says, example 1 says, graph the function, compare it to the graph of f of x equals 1 over x, and state the domain and range. So remember, step 1 is to draw the asymptotes. So here, let's figure out what our asymptotes are going to be. It says x equals h and y equals k. So let's figure out what our h and k are here. X isn't being subtracted by anything, so we don't have an h, and k, there's nothing being added, so we don't have a k either. So this means our vertical and our horizontal asymptotes are just 0. After you draw the asymptotes, I want you to put this function in your calculator and draw what you see. Okay, now after you've drawn your graph, we need to figure out what the domain and the range is. So it looks like, remember the domain is the x values. It looks like it keeps going to the left. And if you see here, it also keeps going to the right. So it would be all real numbers. But since it never touches the 0, then the domain is going to be x when x does not equal 0. Now let's do the range. The range for this function, it looks like the function keeps going all the way down and it keeps going all the way up. It should be all real numbers. However, we have an asymptote, right? And it never touches y equals 0. So our range is going to be y when y does not equal 0. I want you to go ahead and try to do part B of this example. And I'm going to move on to example 2, part A. Okay, so for this one, we just have to graph the function and state the domain and range. So remember, step 1 is to figure out what h and k are, our asymptote. Okay, this time we are given an h and a k. H is 3 and k is 5. Our next step would be to draw our asymptotes. So x equals 3 right about here, and then y equals 5 right here. After you're done drawing your asymptotes, I need you to go ahead and put your graph in the calculator, put your function in the calculator, and draw what you see. Okay, after you finish drawing it, we need to figure out what the domain and the range are. The domain is the x values, so the x values, it seems like the function keeps going left all the way to negative infinity, and it also keeps going right all the way to positive infinity. So it would be all real numbers, except for we have an asymptote at x equals 3. So the domain is x when x does not equal 3. And then the range, same thing. We're looking at our y values now. So it looks like the function keeps going all the way down to negative infinity, but it also keeps going up all the way to positive infinity. It would be all real numbers. However, we have an asymptote at y equals 5, so range is y when y does not equal 5. Now go ahead and try part B on your own, and that's it for today's notes.